Okay, so sorry for the interruption because of that 40 minutes constraint. Now look here. This work is electron is a negative charge, right? You know that E dot dl. Okay, so we have this situation. We have this situation. Uh, uh, this is case for negative charge. Okay, case for negative. Now let's try to see the same thing for positive charge. Look here. Suppose, so suppose we build another case for positive charge. Okay, now see. Say you have this positive charge, you have this negative charge. Okay, and see this the separation between the two. This is say point A, this is say point B. The separation between the two say R. Of course, there's a force F, and that is also making electric field intensity E. And now look here. Now suppose we have positive charge. Okay, positive charge. What will happen to this positive charge? This positive charge will move in this direction. The field done by the work done by the field. So W is equal to F dot dl, right? And let's say it's from point A to point B. And what was F? F is the charge into electric field. Okay, so this is the work done. This is positive charge. Just focus on this, okay? Uh, just focus on this. In the previous case, we took electron, which was a negative charge, okay? So we have all these calculations, okay? Just you need to consider the negative for the charge also. Now we are taking the positive charge. So the kinetic energy which this electron will gain will be in this direction. And this is the kinetic energy. Okay, this is the kinetic energy to the right. And it is the work done by field. So we take work done by field positive. That is the positive work for positive charge. Okay, look here, work done by the field. Okay, which one is the work done by the field? This one, work done by the field. Okay, and this work done by the field is positive. Okay, on a negative charge. Do you understand this thing? Work done by the field is positive on a negative charge. This negative sign is because of negative charge. You should understand the difference now. Now coming back here, that the case of positive charge. If you try to move this charge in this direction, if you try to move it in this direction, okay, if you try to move the charge in this direction, that's the external work. Okay, external work. And how much it would be? W equals to minus Q. Minus Q. What should be the E dot dl? What should be the starting point? It's from B, point B to point A. Look here. This was point A to point B, A to B, A to B. It was say coming from this. Now this is from B to, this is point B. This is point A. Now it's from B to A. Is this clear? Just a flip of integral direction, you get the, so this external work is work done by external source, work done by external source, and this work is negative, negative on a positive charge. Is this clear now? Can you see the difference? A little twist. Okay. Can you recognize these two cases now? The case which was for the negative charge and the case which is for positive charge.
Yes, sir.
This is the case you find in books. In books. You find this case in books. Okay, the previous case is not listed in the books. Why? Because in books you could take the conventional current. Okay, so what's the whole idea? What's the whole idea? What's the whole idea? The whole idea is if you move,
And for positive charges.
yeah, yeah, if you move, uh, if you, the whole idea is, say this is the, say this is V plus, and say this is V minus. Of course, V plus is made by positive charges. That's why you call it positive potential, and V minus is made by negative charges. Okay, is made by negative charges. So, so, so electric field is in this direction. Okay, this is the electric field. Electric field is in this direction, right? Now the idea is whenever you move, say the electron in this direction, or say the electron is moved in this direction, just two different cases. Okay, okay. If electron moves in this direction, that will be the work by field. If the electron moves in the other direction, external work done by external source, right? So there's a little difference, and the difference is only this in the sign. Okay, but the whole idea is whenever charge moves in electric field, whenever charge moves in the electric field, uh, that is by field, or by external source. Okay, by field or by external source. So whenever charge moves in the electric field, there you have two possibilities. Either it is moved by the field or it is moved by the external source against the electric field. You have two sources. Work done. Work will be work will always be how much? W equals to charge, right? From A to B, okay? Or from B to A, okay? If say this is your point A, this is point B. So my purple work will be A to B. Sorry, purple work will be from B to A, right? And the yellow work will be from, sorry, the yellow work will be from A to B, okay? The purple work will be from B to A, right? So generally, generally I would put path here, okay? So if I consider the yellow work is from B to A, from B to A. If I consider the purple work is from A to B. Okay. So this is path. This is also path of integration. Okay. So this is very general thing. Very general. Okay. Uh, and what should I put? E dot dl. E dot dl. The path. E dot dl. Okay. E dot dl. The path. Okay. Is this perfect? Whenever you try to find the work, you have to consider E and then the path. Whenever you try to find the work, you have to consider E and then the path. Now coming to this case, how much electric field I have? How much electric field I have for this line of charge is given here. Now, if I try to move an electron, say this is your point A and say this is point B, and if we try to move the electron from here to here, this will be the work done by what?
Sir, field.
By the field, exactly. And say the electron comes here, okay? So when you try to move the electron against the work done, this will be the work done by
External force.
External.
okay? So it's so easy. It's very easy. Look, the work is integral of path E, which was here, dot dl, dot the path. It's so easy. And you just put charge here. So you need to use this equation to find the work done, of it's so easy. Look, it's so easy to find the, say this is the line charge and you want to move the charge from this point to this point, you have to use this one equation. Work equals to charge E dot dl. Or if you want to move the charge from here to here, again you have to use the same equation. Just define this path. Only define this path and you will be able to calculate the amount of work from one point to another. Either work done by the field or work done against the electric field. So it's so easy to calculate these work done by the field or work done against the field. Okay, any question with this? Any question here? No question?
No.
No question? Okay, so shall we start explaining the work done by the work done by the uh, work done in the field of this line charge. Okay, so here we have rho L, charge divided by length of the wire. Okay, so now suppose this is my point B and this is point A. So I have these 2 points. This is point B and this is point A. Okay, so what if I try to move a charge from here to here? A charge from here to here. How much work is required? How much work is required? Okay, if you move a charge from here to here, how much work is required? So again, it will be very easy. The charge is given to you. Electric field is given to you from here. Just put it here and your path is DL. Okay, it's from B to A. So we have the same equation. W equals to minus Q E dot DL. Minus Q and D path is what? Path is from B to A. And what is E? What is E? This E is this much. Okay, E is this much. And what is DL? DL is rho d rho. DL is actually DL is d rho. D rho is actually your DL. Okay, DL, which goes this way. This is the rho direction. Okay, so this little path is d rho, rho d rho. So this is DL. This is electric field E. This is electric field E from this equation. Okay, so just plug the values. Okay, knock out some constants. You will left with one rho, which is the distance. Okay, so you know that this point A has the x component and the y component. This is the y component of it. This is the x component. This is x of A and this is y of B, y of A. Okay, so this factor is x square, A square plus y, A square under root. So this is the point A, yeah, and this is the point B. Okay, so plug the values and you will get the answer. Okay, so this is the amount of work in the field of line charge. Any question here? Any question here? No question? No question?
No, sir.
Okay, we will continue with this example in the on-campus class and we will find few interesting things about it. Till then, take care of yourself, your families. Stay blessed.
Okay, sir.
Allah Hafiz.
Okay, sir. Thank you. Allah Hafiz.
Allah Hafiz, sir. Allah Hafiz.
हाफिज किसी की अटेंडेंस रह गई बता दें
सर मेरी रहती है सर
नंबर क्या आपका
41 41
Sir, Usama scored 23.
सॉरी 17
41 सर
41 हो गई है
19.
18, sir, 18.
Usama scored 23, sir.
23
18, sir.
18 हो गई है
44, sir.
let me inform you about the absent today. Muiz is absent. Wajul Hassan is absent.
Sir, मैं present हूँ sir 7.
7 is present. Okay. Okay.
06 is present.
0?
6.
06 is present. Yeah. Okay. 20, Hamza is absent. And then Hamas is absent. Where is Hamas, by the way?
08 present है sir.
08 present है, 25 भी present है.
Okay,
Okay.
sir. Thank you.
And
Sir, 14
then,
भी present है.
yeah, 14 भी present है. Okay, Hamas and Osama is absent. Osama Khalid. Okay. And Osama Ali. Osama Ali, are you there?
Yes, sir.
Osama Ali, आपका नाम LMS पे नहीं आ रहा. प्लीज अपना इशू रिजॉल्व करें क्योंकि अभी आपकी अटेंडेंस कोई लगी नहीं है. ठीक है?
Okay.
53 is present or absent today? आदिल हुसैन है आज? आदिल हुसैन आया हुआ है? नहीं आया? Okay. Okay, thank you so much. Thank you. Thank you. Take care.
Thank you, sir. Thank you.
Allah Hafiz, sir. Take care. Goodbye. Have a sweet dreams.
Allah Hafiz, sir.
God bless you.
Sir,
Thank
Allah
you.
Hafiz.
Where is daytime, not the time for dreaming. Okay. Anyway, I'll take that. Allah.
Allah Hafiz.
Okay.